So let's get going with question 1. So here we have a table which shows us the value of $1 Australian being converted to $1 from the time period of 2012 to 2022. And it gives us an example, which is helpful. So you'll see me highlighting and underlining things as we go along. So it says at the start of 2015, the value of $1 Australian was $0.81. Okay. So try and give you an idea of what's going on when using this table. But what question 1 wants us to do, it says, for how many of the 11 years was the value of $1 Australian greater than, so that's important, greater than $1 at both the start and the end of the year? So first thing, where it's mentioned the start and the end of the year, let's just make it clear that that's what we're focused on. So we're focused on the year start at the moment. So here's our values for the start of the year, and we're focused on the year end. Because it could be tempting to look at the other columns to help us answer this question, but it's not actually information that we need to consider at the moment. In terms of the concept that we need to know to answer this question, I would say it's probably knowing that when you multiply by a number that's greater than 1, you're going to get a larger value. It relates to percentages. 1 is 100%. Anything greater than 1 is greater than 100%. So any of these numbers which are larger than 1, we're actually going to end up with a larger value. It's a different currency, but you're going to end up with more than you started with. So let's have a look at the values in this table, which are larger than 1. We'll highlight them. So we've got one here, which is 1.05. We've got another here, which is 1.04, and another 1.04 over here. Every other value within these two columns that we're interested in, at least, is less than 1. The question says, for how many years was the value of $1 Australian greater, both at the start and the end of the year? So in 2013, you would have been greater at the beginning, but at the end you would not, because this is 0.89. So actually, the only year where the value was greater at the beginning and the end is 2012, because you can see here 1.04, both at the beginning and end. That's the only year where both of those numbers have a larger value of 1, and hence you would end up with more. So the answer to that one is 1. Right, let's scroll down, see what question 2 wants us to do. In which of these years did the value of $1 Australian in US dollars show the greatest change between year high and year low? So this time we're focusing on year high and year low. I might just use the blue pen here to emphasize what columns we're looking at this time, because it's easy to mix them up. So we're now interested in these two middle columns. So we're looking at the year high and the year low, and we're looking for the greatest difference. So I'm just going to do a big circle around all of the numbers that we're now interested in. And we're looking for the greatest difference, but use the multiple choice aspect as well. So we got 2012, 2013, 2020, and 2022. A key word here is change. I've kind of automatically used the word difference, but with practice, hopefully you'll know that change means to subtract. So does difference, and hence I swapped them over there. So we're looking for the biggest number when you subtract either the year high from the year low or vice versa. So let's have a look at what we get. So let's start at the bottom. In 2012, our year high is 1.08 and our year low is 0.9. So I'll use the calculator over here. So we've got 1.08. Okay. Let's see if you'll let me do this. 1.08 subtract 0.97, 0.11. So the change between lows is 0.11. For the sake of time and its multiple choice, you might not want to put every single one onto a calculator, but just for transparency and making sure you understand what's going on, we'll do it this time. But when you have multiple choice questions, you might be able to start eliminating some of the options a bit faster. So another option was 2013. So in 2013, the year high was 1.06 and the year low was 0.9. So the change between them is 0.17, which was more than 2012. At the moment, 2013 is the biggest one we have. Let's have a look at 2020. This one, I would argue, try and maybe do that mentally. Hopefully you can see that 0.77 take 0.57 is going to be 0.2 or 0.20, which is more than what we have so far. So straight away, you might have been able to eliminate the earlier options because you can see that that option is going to be more. And then the last one was 2022. So 0.76 take 0.62, 0.14. So the one that had the biggest change, the biggest difference, let's highlight it, is this one here, because when we did 0.77 take away 0.57, that was 0.2, and that was the biggest number we got when we did that process. So the answer to this one here is going to be 2020, option C. And whilst we're just talking about it, there's a lot of resources to which you can do on paper, but at some point do use the online versions that are available through some of the universities, because you want to get familiar with how you would choose option C, for example. But there we go. That's question 1 and 2. Moving on, we have question 3. And it says, in one Australian jurisdiction, a guidance for planning child care centres concerns the provision of natural light. So we have to have enough natural light, basically. It says childcare centres should have a total window area of not less than 10% of the floor area in the room. So this is important. So whatever the area of the room, the window has to be at least 10% of that or bigger for it to be acceptable. Otherwise, there's not enough natural light. So let's have a look at what we have. It says, below are some combinations of floor and window dimensions. Does each combination meet the guideline? We're going to assume rectangular windows here, as well as a floor plan. We are having to use some prior knowledge, I guess, or what is most standard. If things like that come up, just rely on your instinct. So yes, you can get some different shaped windows, but you know, most of them you're going to see is in the form of a rectangle. So let's go ahead and do a quick sketch of what's going on. Just going to make sure I have my blue pen. So the floor is 7 by 9. So if I had a rectangle, 7 by 9, not perfect and not to scale by any means, but hopefully we would know that if I wanted to get the area of that rectangle, I just have to times these two numbers together. I won't go into tons more detail at the moment, but if area is a tricky concept, then I do suggest watching some other videos to help you understand why we do this. But the area of the floor, based on the fact that those measurements are 7 and 9, is going to be 63 meters squared, 7 times 9, okay? 63 meters squared. Now, this is where you might want to do some estimating as well, because 63 meters squared, that's close to 60. And you might know that 10% of 60 is 6. So I'm going to expect I need something more than 6, all right, to fit the criteria. The window is actually 3 by 2. So the area of the window, which is 3 by 2, I'm just going to do it this way round. Just looks a bit more realistic. 3 by 2, 3 lots of 2, or 2 lots of 3, you get the same answer regardless, is going to give you 6 meters squared. And as I mentioned, 10% of 63 is going to be more than 6, because 10% of 60 is 6. If you're not too sure how you would go about checking, I will show you on the calculator. I encourage people to know that percent means out of 100. There is a percent button on the calculator, but I find that it just confuses people, and quite often a few things go wrong. If you're confident with using it, feel free. But if 10% means 10 out of 100, 10 divided by 100, because just emphasizing again, percent means out of 100, I want to do 10% of means to multiply. So 10% equivalent to 0.1. So 10% of, I'm going to times that by 63. 10% of 63 is 6.3. I'm only going to fit this criteria if I have a window area, which is 6.3 or more, and I don't. Okay. So for that first one, we're not fitting the criteria. So no, we're not fitting the criteria or conditions. The next one here, we've got a floor, which is 8 by 8. So 8 by 8 is 64. Now the window is 1 by 2, but there's a little bit of extra detail there that if we're not careful, we will get caught out. So you might have noticed that there's actually 4 windows. So 1 lots of 2 is 2 meters squared, but I have 4 of them. So I've got 64 meters squared here. I've got 2 meters squared as a window, but there are 4 windows. Okay, so if I just put here 2 times 4 equals 8 meters squared, because I have 4 windows, not 1. So I have a floor area of 64. Let's figure out what 10% of that would be. 10% of 64 is going to be a little bit more than 6. So you might already be thinking, yeah, 8 meters squared is enough. However, we'll just confirm over here. So we're going to do, we want 10%, so 10 over 100 of, so multiply 64, 6.4, anything which is 6.4 or more would be good enough in terms of window space. And we have 8. So yeah, we're fine here. We fit the conditions, we fit the criteria. In fact, they use the guideline. Yeah, we hit the guideline. Okay, moving on. Question 4. So we have a store here who sells 50-litre bags of soil in order to help us fill this planted box where the dimensions are given on the diagram. So let's have a look. Again, to get the volume of this shape, you need to multiply these 3 numbers together. I'm not going to go into a huge explanation of why, but if volume is one of those things we're unsure of, I would recommend you just have a look at some of the other videos. Mass Antics is a great place, which could give you a nice visual understanding of volume. But we need to multiply these 3 numbers together. You can do it on the calculator over here if necessary. You might be able to say 2.4 times 1 is still 2.4 times in 1. You'll just get the same answer. Then times by 0.5. 0.5 is equivalent to a half. So you will get 1.2 meters squared. By all means, use the calculator if needs be, because the large majority of the Numeracy LANTITE assessment is on calculator. So use it if necessary. We're told that the 50-litre bags of soil are sold by the store, but we're also told that 50 litres is equivalent to 0.05 meters cubed in volume. So one thing I have done here is I've put meters squared, but I'm not going to edit this out because I want people to realize that it's okay to be human. All right. It's not about getting everything right perfectly from the get-go. It's about being able to go back and check and say, all right, there we go. It looks like there may be an error here. The reason that it's cubed is because we're doing a 3D question, by the way, just in case you're wondering. So I could either change this to litres and then see how many times 50 goes into it. Or if I'm told that 50 litres is equivalent to 0.05, I could see how many 0.05s go into 1.2. What I can't do is I can't do a calculation where one of the numbers is in litres and the other number is in meters cubed. Yeah, you've got to have the same unit. But here, considering I've got this number already, I want to see how many times 0.05 goes into 1.2. This is in meters cubed. This is in meters cubed as well. So that will work. It will give me my answer. So let's do it. So 1.2 divided by 0.05, 24. And there you go. That is your answer. So I'm just going to use green so it's nice and clear. My answer is 24. If you wanted to, you could have changed 1.2 into litres and then divided it by 50. But I honestly think that's going to be longer than necessary, considering we've got 2 numbers which are both in meters cubed already. Why not use the quickest approach and use the 2 numbers where we have the units the same already? Last question for this part of the video. So question 5. This is quite common in LANTITE. You've got some true or false. In more recent years, they put the unable to determine option as well. So let's have a look at this one. So we've got, in 2019, there were 2,000 students who were surveyed between the ages of 12 and 25 about their confidence in certain subjects. And they could choose from not confident at all, which is represented by white. And then it goes through the different shades of blue. The darkest shade of blue represents very confident, whereas the lighter shades are not really confident. Kind of in the middle is neither, etc. So let's have a look at the statements and see how I would go about determining whether they're true or false, or whether we don't have enough knowledge. So the first one, it says the STEM subject with the lowest percentage of students who reported they are somewhat confident or very confident was engineering. Let's just get our highlighter out, because it says somewhat confident or very confident. If you see the word or in mathematics, it's hinting you to add them together. So one approach I could take is I could add all the percentages together, but to be honest, I don't recommend it, because there's a quicker way, and I'll show you how we can do it. So let's highlight all the sections which are very confident or somewhat confident. And the reason that I say don't add the percentages together is we're using the same scale for this diagram. Yeah, otherwise we couldn't put it all on one graph. It would be inaccurate. So if I highlight all the different parts on these bars, which represent somewhat confident or very confident, we can just then focus on how much of the bar has been shaded in. So science goes to this point here, technology is a little bit further on. So when looking from the right-hand side to the left, engineering is, I haven't highlighted much there at all in comparison to the others. And then maths is about there. So 10% at 20%, 10% at 27% is 37%, which you will find is not as much as the other subjects. But I don't need to add up the percentages of all the other subjects to see visually that it's not really even close, to be honest, in comparison to the other three. Yeah, it does have the lowest percentage. That's definitely true. Yeah, in comparison to the others, it's not near. Okay. Next one, more than 100 students reported they were not confident at all in technology. That is sneaky, in my opinion. And the reason being is if I scroll up here, is there's 2,000 students between the ages of 12 and 25 were surveyed. If you didn't pay close attention to that part there, you would easily skip over it and hence not realize that you could do this. So completely understandable if a few people would get that one wrong, because the information you need is up here. I'm just going to rub it out again, or attempt to. I'll use a highlighter. Yeah, it tells us here that 2,000 students were surveyed. Otherwise, without that, we wouldn't be able to do this. So more than 100 students reported they were not confident at all in technology. Let's go to technology. And it's not confident at all is represented by 4%. So 4% of people are not confident at all in technology. So we want 4% of 2,000 because there was 2,000 respondents. So I'm just going to put here 4% of 2,000. So you might be able to do this with some mental maths, but like I've said, we have a calculator, so let's use it. So we want 4%, 4 over 100 of referring to times 2,000 respondents or 2,000 people surveyed. And like I said, that was a bit sneaky, but it does tell you right at the top there was 2,000 people who answered, and that's 80. 80 is less than 100, so the answer to that one is false. And then last but not least, it says the students who reported they were very confident in science were the same students who reported they were very confident in technology and maths. We don't know this, yeah? So we've got the percentages of people who voted one way or the other, but we don't know who those people are, yeah? Let's just make up a person and call her Anne. We don't know how Anne responded to science, technology, engineering, and maths. So we do know how many people there was, and that was kind of slyly put in there, but we definitely don't know what people chose their confidence level with each subject. So this is an example where we are unable to determine. So there we go. If you found this useful, we will be doing a part 2, 3, and 4 in some other videos, but I would also greatly appreciate it if you subscribe, check out the rest of the channel as well as the description below. where there'll be a few freebies to help guide you along your LANTITE journey. So I look forward to seeing you in part 2, hopefully, and enjoy the rest of your day. All the best for whenever it is that you are taking your assessment.